All right, everybody, I hope y'all are doing good. Let's go ahead and get into this question with Orgo. So it says to draw 4 constitutional isomers of C3H9N. So we got to remember that a constitutional isomer is something that has the same formula, C3H9N, and it has a different connectivities. And when we mean connectivity, we mean the way the atoms are arranged. So now that we're in organic chemistry, we should have a good idea about how to draw Lewis structures. And so I'm not going to go through the full details on how to draw Lewis structures. If you need help with that, let me know offline. And so let's go ahead and get into it. And so the way that we would want to approach this problem is to think about all the different ways that we can connect the carbons and the nitrogens together. Now, we don't really have to think about hydrogens because, hydrogens are never the central atom, and they're always going to be used to make octets. And so we really then that leads us with, well, how do we arrange the carbons? And so let's think about the way that we can arrange the carbons, and then we can stick the nitrogen in there too and see how that happens. We know that we'll never have a hydrogen with more than one bond. So what that means is that hydrogens will always be around carbons in some way, shape, or form, or they'll be around nitrogens in some way, shape, or form. And now a nitrogen will need 5 electrons to have a 0 formal charge. So typically a neutral nitrogen will have a lone pair. So let's take a look at all the different ways we could do that. 1, 2, 3 carbons in a row, and then a nitrogen. That's a possibility. Now, one thing about drawing Lewis structures is to remember that if I draw the nitrogen first and then 3 carbons in a row, that's exactly the same. So I'm not going to consider that as different. So let me fill in the rest of the hydrogens to complete my Lewis structure. If you were to count up all the lone pairs of electrons or all of the valence electrons for all of the atoms, you would see that we have all of them listed, and this is a good Lewis structure for C3H9N. So that's one possibility. Now, the other possibility is that the nitrogen can be connected to 2 carbons. And so remember, if I have two carbons on the left, it's the same as having 2 carbons on the right. It doesn't matter because both of those are the same structure. So let's go ahead and fill out the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. And so that's all the different ways to work on this particular structure. Now, there's also other ways to draw constitutional isomers of C3H9N. Remember that the nitrogen can be connected up to 3 carbons. So I can have nitrogen, carbon, 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 and then a lone pair. And so now I want to do is just fill in those 9 hydrogens. Done. So there's yet a third way to draw that structure. So one more way, one more constitutional isomer. Recall that carbons can be branched as well. And so here's the final way to draw that constitutional isomer. So I need another hydrogen here. Let me actually clean that up just a little bit. And then here are the last 6 hydrogens. Okay, that's it. There's no other ways to do it. Remember, if I just move the carbons to the other side, then I'm looking at the same. Oh, wow. Looking at the same structure. Oh, God, I'm sorry. I got confused. I thought there was 2 similar structures. We got all 4 unique structures. So for structure number 1, structure number 2, structure number 3, and structure number 4. Now, you could use some line structures to represent this. Structure number 1 would be 1, 2, 3 in H2. Structure number 2 would be N 1, 2, like this. Structure number 3 would look like this. And structure number 4 would look like that. Okay, great. That's all there is to that.